Hello everyone, welcome to ANZ Summit 2022. My name is Pratima Singh and I'm a solutions architect at AWS based in Sydney, Australia. If managing patches is an operational roller coaster for you, then you're in the right session. As most of us understand, vulnerabilities are weaknesses in systems that can be used by third parties to potentially gain unauthorized access into your environment. Now, through this session, we will first establish what kind of dark magic vulnerabilities really are. You'll be surprised, or maybe not, to see that they are trending. Then, I will introduce you to my friend Tom, and we will discuss scenarios that his team is struggling with, diving deeper into solutions. Now, this session would be incomplete without a customer example. So today, I will showcase the current state of how Canva scans containers, along with an insight into their future state container scanning workflow using their CI/CD platform. And we will conclude with building out a centralized patch management solution for Tom using our learning from Canva's design, using native controls with AWS services like AWS Systems Manager, Amazon Inspector, and AWS Security Hub. So where do vulnerabilities come from? Do they just magically appear? Maybe some unicorns are at play. Well, not really. As with most things, we humans create them. They are in the software we write, and also in the configurations we build. A large portion of vulnerabilities come from software made by other humans. Now, such software includes third-party libraries and the operating systems that enable us to run applications on servers. Because operating systems are extremely critical for helping us operate in an IT environment, keeping them vulnerability-free is the most essential. With increased use of internet and IT-based systems across the globe, one kind of software in particular saw a massive growth, the vulnerable kind. Now, vulnerability management isn't really a new concept. Vulnerabilities have existed ever since software has. But since 2016, the number of vulnerabilities recorded year on year has shown an upward trend. Vulnerabilities can exist in software due to multiple reasons. The speed of digital transformation has increased, with more organizations shifting focus to building digital assets. Now, in order to catch up to competitors, teams rush through the software development lifecycle, and often it's the testing phase that takes a hit and is rushed through. This is one of the primary reasons why vulnerabilities in software stay undetected. But some vulnerabilities, the particularly sneaky ones, could be dormant for years, lying undetectable, till someone gives a real hard look. I'm sure most of us remember how the Log4j-based vulnerabilities took the internet by a storm late last year. It is quite evident, isn't it, that with the pace at which technology is changing and new features are being developed, teams are overwhelmed with the effort involved in keeping servers up to date with the latest security patches. Now, my friend Tom was no different. Tom's organization in the last year made a strategic move to AWS and adopted a cloud-first approach with all new product and feature launches. Now, Tom is the head of security team that has a few compliances to adhere to, PCI DSS and CIS to name a couple. On their migration journey, they hired Jerry as the lead for cloud platform team. Now, Jerry's team is tasked with building applications and deploying them straight into their AWS environment, reducing the on-premises footprint. But Tom looked worried. He said, "You know, Pratima, I am very happy with the move to the cloud. We have been able to achieve success on so many fronts, but our patch management strategy is breaking down. We just didn't think it through. Further conversations with Tom revealed that towards the end of 2021, the Log4j-based vulnerabilities really did a number on his team. His team was working long hours, through the weekends, and some even through the New Year's break to update the servers and applications where the vulnerabilities existed. Now, Tom's team wanted to scan and patch 100% of their environment. But as their hybrid environment scaled, they spent a significant amount of time trying to discover their entire ecosystem. Their enterprise-grade licensed solution doesn't work well with cloud-based instances. Moreover, with AWS, the developers decided to use operating systems other than the one vetted for on-premises systems, primarily because they were better fit for their cloud-based applications. And then Jerry's team started to build applications in containers to speed up time to market further. Now, Tom is looking at 3 different solutions to solve one challenge, along with scaling out their AWS footprint in a secure manner. Now, take a second to absorb all of that. It is a complex challenge, right? But before I can start to build out any solution for Tom, I had to remind him of the shared security responsibility model when using AWS. This would help him work out priorities for his team. Security and compliance is a shared responsibility between AWS and the customer. As per the shared responsibility model, AWS is responsible for security of the cloud, which includes protecting the infrastructure that runs all of the services offered by the cloud. Now, this infrastructure includes the hardware, the software, the networking, and facilities that run the AWS cloud services. But as a customer, Tom's team is responsible for security in the cloud. Customer responsibility is determined by the AWS services that a customer uses. In Tom's case, specific to patching, this means that when using Amazon EC2, his team is responsible for management of guest operating system, including updates and security patches. With containers, Tom's team would be responsible for application and runtime level patch management and updates. Now, let me break down his concerns into smaller challenges. First, talking about the servers, there are on-premises virtual machines and EC2 instances in play. Second, there is an uptick in the use of containers. Third, Tom wants a centralized solution without having to change tools. He also wants a level of access management where teams can view the scan results but without administrative access to the tool. All right, now taking them on one by one. First, addressing the server scenario. The team's primary challenge is discovery in a hybrid environment. Add on to that the need for developers to be able to experiment using the agility offered by AWS. Also, Tom's team wants to build a workflow allowing them to not only scan and patch servers on demand, but also on a schedule, while ensuring approved patches make their way in the servers. To demonstrate how Tom's team can achieve their goal, I will use AWS Systems Manager's Patch Manager feature to centralize and automate patch management. I'll be working through the configurations with a bit of a pace, so I'd recommend focusing on the capabilities and controls. Virtual machines on premises, instances on AWS, and edge devices can all connect to the AWS Systems Manager by running a single agent called the Amazon SSM agent. Once the agent is running, all servers are visible as managed nodes under the Fleet Manager in the Sessions Manager console. This gives Tom's team an inventory of all servers running in the organization's hybrid IT environment. Let us take a deep dive into Patch Manager and see how it can address the team's patching requirements. For this demo, I will create a patch baseline for EC2 instances running Windows operating system, including an approved patch. The Patch Manager dashboard gives a view of the patching compliance status of servers, including previous runs and links to their outputs. Teams can either choose to use a predefined patch baseline or create their own custom patch baseline. When creating a patch baseline, teams have the capability to toggle auto approval settings to ensure the servers always get the latest patch. If a patch is reported as missing, compliance reporting level determines the severity of the compliance violation. Teams can also configure a list of approved and rejected patches. I am adding an Office 2010 related security patch as an approved patch with critical patch compliance level. Now, associating a value of the tag patch group with the patch baseline ensures that all servers with the matching tag value must be compliant to the patch baseline. I have updated the tag on the target servers to match the value for the patch group. Teams can choose to skip scheduling altogether by choosing the Patch Now option while configuring patching to scan instances on demand. They can choose either to only scan or scan and patch in the same run. Teams can also configure patching to run on a schedule. The schedule can be a cron or a rate-based expression and is called a maintenance window. Once the window is created, it is reflected in the Maintenance Windows section of the Systems Manager console. Once patching is configured, the Patch Manager dashboard shows current and past patching runs with a link to their output. Now let us recap the service-related requirements with Patch Manager. I have been able to address discovery in a hybrid environment, including handling multiple operating systems. Teams can scan and patch on demand and use maintenance windows to run patching operations on a schedule. All this with a patch baseline that allows teams to configure a list of approved patches, along with duration-based approval. I still, however, hadn't addressed the challenge with containers. As agile and portable as containers are, it can often be a trick for security patching to keep up with the speed of development. Looking back at Tom's team's concerns, they wanted to be able to scan and patch all of their environment. With containers, they wanted to scan images as soon as they entered the ecosystem. They would love to be able to continually scan images and also not have a situation where an image that has passed the scans could be overwritten by an image with vulnerabilities. As with the previous demo, I'll be working through the configurations with a bit of a pace, so I'd recommend focusing on capturing the capabilities and controls. When working with containers, I recommended Jerry's team use Amazon Elastic Container Registry or Amazon ECR as the image repository to automatically discover container images and versions to scan. Teams can choose to enable enhanced scanning to continually scan images or scan when images are pushed to a repository, or even build a custom approach through filters. Teams can also ensure the integrity of images through tag immutability. Now select the private registry option to view the scanning configuration. Here we can see continuous scanning is enabled by default. Now I will add filters to build a custom configuration. I want to scan all images on push for all repositories except for the ones with log4j in their name. These must be scanned continuously. A quick preview and we are set. The changes are now visible in the scanning configuration along with filters in play. Let's head back to the repositories console, where you can see the scan frequency has been evaluated based on the scanning filters. The repository with log4j in its name has been marked for continual scans. The other observation is that a couple of the repositories don't have image tag immutability configured. Let us first edit the repository settings and enable image tag immutability. This means that an existing image tag cannot be overwritten by pushing the same tag with different contents. We can now see the tag immutability enabled for my super secure web app repository. Now let us see what an image scan result looks like in the ECR console. Select a tag and see findings for the tag. This is where teams working with containers will be able to see all CVEs reported by the scan along with severity, the package which has the vulnerability, and a description of the vulnerability. Each of the vulnerability identifiers is linked to a finding in the Amazon Inspector service. By clicking on one of the identifiers, it takes me through to the Amazon Inspector console. Each finding in the Amazon Inspector console is associated with a unique finding ID, which is visible on the top right when you click the title. You can see the details of each finding and also the impacted resource, which in this case is a container image. We can also see the inspector score with each finding in comparison with the actual CVEs score. The inspector score is a highly contextualized and meaningful inspector risk score for each finding to help teams set more accurate response priorities. Removing the filter lists all findings in the inspector console. Now these are also visible in the Amazon ECR console, which means that along with aggregated results available in Amazon Inspector, teams have the flexibility to view the same results in the tools they use for their day-to-day tasks. Now, recapping on the container's requirements, Amazon ECR addresses the challenge with discovering container images. Combined with Amazon Inspector, the scan on push and continual scan configuration helps Tom's team stay on top of any changes. And finally, enabling image tag immutability preserves the image integrity. Today, I have the privilege to talk about Canva. Consistently ranked as one of the world's fastest growing technology companies, Canva is an Australian independent software vendor offering its visual communications platform to more than 75 million monthly users across 190 countries. Canva's vision is to allow anyone to design anything and publish anywhere. And container-based applications play an essential role in Canva realizing that vision. Canva uses Amazon ECR and Amazon Inspector to centralize and continually scan container images. Integration with AWS Security Hub enables centralized management of vulnerability scans. Now, this helps allocate patching issues to teams based on priority. This architecture allows Canva to control dependencies and be confident that they are free from vulnerabilities. This setup was immensely helpful to validate that Canva's applications were unaffected by the log4j-based vulnerabilities. Scan the QR code to know more about Open Policy Agent and how you can use it to ensure only verified container images are deployed to Kubernetes clusters. But Canva did not stop there. They are now building a container hardening and promotion workflow in AWS using their CI/CD platform. It is a 4-step process triggered when a change is made to a container repository. A scan is triggered for the image using Amazon ECR and Amazon Inspector. The findings are then fetched by the next step, and the image metadata is updated in an Amazon DynamoDB table. Now, based on the scan results, container images are promoted, and subsequently a notification is issued to the team's collaboration platform along with updating their engineering workflow management tool. Coming back to Tom, let us now tie the solutions with Tom's concerns. His concern around discovery, scanning and patching of heterogeneous operating systems in a hybrid environment, on demand and on a schedule, is resolved with Patch Manager. The concerns around discovery and patching of container images while preserving their integrity is resolved with Amazon ECR and Amazon Inspector. Now, our final challenge is to bring it all together so that Tom's team has a centralized view of all findings. Learning from our friends at Canva, AWS Security Hub looks like the missing piece of the puzzle. AWS Security Hub natively integrates with AWS services like Patch Manager and Amazon Inspector. It supports cross-account and cross-region aggregation. It also integrates with AWS organizations. This enables Tom's team to manage access to the tool. Jerry's team can view all aggregated findings in a single view without affecting any change in the configuration of the tool. And Tom's team can perform admin activities like integration with third-party tools. Let us take a quick look at AWS Security Hub's features and controls. Security Hub gives the team capability to automate and centralize security checks. Teams can aggregate findings from multiple accounts and integrated services. Teams can use the product name filter to list all aggregated findings from a single service. In our case, we will focus on Systems Manager, Patch Manager, and Inspector. All findings are listed with the resources generating the findings. Now, in addition to that, Security Hub supports automated and continual checks for CIS, PCI DSS, and AWS foundational best practices. The summary page shows the compliance score across enabled compliance standards, a range of auto-generated insights along with links to findings from integrated services. A central hub, as the name suggests, to manage and improve security posture. Now that we have aggregation through Security Hub, Tom's team can configure multiple actions. They can ship all findings to the organization's chosen security information and event management tool, or SIEM tool. They can configure remediation actions through the custom actions feature of Security Hub, and even configure notifications based on the findings details. Now, this patching solution has been able to address all of Tom's concerns without him having to sift through multiple vendors, software, configurations, and dashboards. His team can easily get a consolidated view of all servers and container image repositories in an automated and continuous fashion. The cherry on the top for Tom's team, who are involved in manually remediating the vulnerabilities, is being able to use an AWS Solutions implementation to configure automated response and remediation with AWS Security Hub. Vetted by AWS and compliant to the AWS well-architected framework, the solution is broken down into 4 workflows: the detect, ingest, remediated, and log workflow. The detect workflow collects events and data from integrated services. The ingest workflow uses Security Hub's custom actions feature to initiate remediation. The remediate workflow, as the name suggests, performs the tasks needed to remediate findings. And finally, the logging workflow logs the results, sends notifications, and updates the Security Hub finding. The solution implementation supports one-click deployment through AWS Cloud Formation templates and comes packed with architecture diagrams and implementation guide. Scan the QR code to access the solution implementation. Now, in addition to AWS Solutions implementations, AWS Samples is a public repository of sample applications and solutions. The AWS Security Hub summary email repository can be used to build a notification framework. This will provide recipients with proactive messaging, summarizing the security posture and improvement within their AWS accounts. This solution first creates 7 custom insights, which include unresolved findings by severity, new findings in the last 7 days by security product, top 10 resource types with the most findings. A CloudWatch time-based event invokes a Lambda function to get the results of the custom findings from Security Hub. It then formats the results for email and sends a message to Amazon SNS. Now, SNS sends the email notification to the address provided during deployment. The email includes the summary and links to Security Hub UI to follow the remediation workflow. Another QR code for you to scan to access the solution implementation. Now, I will share all of the links towards the end of the session, so stick around. Needless to say, Tom went back happy and presented the solution to his team. His team, now rid of manual patching effort, has shifted focus towards building a centralized security and compliance tracking solution using AWS Security Hub's predefined controls and the suite of AWS security services. But wait, there is more. Since you've been such an amazing audience, I am going to bombard you with a few QR codes, so get your phones at the ready. Here is a recap of the QR codes that will help you access the solutions and samples discussed today. But there is more. Scan these QR codes for reference blogs and workshops that would help you build advanced configurations with native controls in order to successfully remediate vulnerabilities. All of these links will be available in the resources section as well. Now, if you like the solutions we discussed today, but you're unsure on how to build skills in-house to implement them, I encourage you to get engaged with our training and certification content today. Scan one or both of the QR codes on the screen to continue your cloud journey. Thank you all for joining me today and being a part of Tom's journey to successful patch management in a hybrid environment. We really value your feedback to help us improve our sessions, so please share your ratings with us. Have a great summit, everyone.